I'm just going to
Well, welcome to today's session. Stellar can DeFi, and so can you. Today, we're going to investigate how Stellar can play an impactful role in the future of financial technology. So today, I invite you on a journey to embark and understand on how Stellar is no longer a sideline player in DeFi, but an active participant. But more than this, it's about everyone in this room. Your capability to innovate, to create, and build great things on Soroban. So without further ado, we'll go ahead and kick it off with speaker introductions. Oh, we're already here, sorry. My name is Julian Martinez, Senior Developer Advocate here at SDF, and if you've ever taken a part of the Soroban dApps Challenge or participated in the Sorobanathon or Hackathon programs, then we're already familiar. And if you've ever watched any of my videos regarding EVM smart contract migration or EVM to Soroban smart contract migration, then thank you for letting me be a part of your developer journey thus far. I'm joined here by my amazing co-host, Chad. The floor is yours.
Hey everyone, I'm Chad. I'm the co-founder of Aha Labs. Willem here on the beanbag is my other half of Aha Labs. We've done a lot with the Soroban CLI developer experience and the NPM generation for smart contracts on the front end side. So that's what I'll be talking about sort of at the end of this talk. So I'm going to sit down while Julian goes through the DeFi part.
That's right. And huge shout out to Aha Labs because they work alongside our core engineers to really bring us the great functionality that we all enjoy in the Soroban CLI and really make the Soroban dApp experience what it is today. So thank you. Here's our contents for today. We'll answer the question, what is DeFi? Then we'll dive into the diverse world of DeFi, drill down a little bit in a more granular level on what a liquidity pool is. We'll answer the question, why Stellar, why Soroban, why do you need both for DeFi? And then we'll do a high-level overview of building a liquidity pools dApp, starting with these smart contracts, and then moving on to the front end for liquidity pools. So first things first, what is DeFi? Is it a digital pond? No, probably not. DeFi is some would say it's the future of finance because it allows us to achieve the financial freedom we never knew we needed. And at the heart of everything is smart contracts, self-executing programs that allow users to agree to logic within code, enabling that customization and overall customability of blockchain. One of the great things about DeFi is that since it's built on blockchain, the access is, it's open to all because anyone with an internet connection can start participating. So, how does this differ from how does DeFi impact centralized transactions and decentralized transactions? Well, in this first model here, we see that Bob sends funds to Alice, but before it reaches Alice, it has to first land within a centralized banking system where they then take full custody of the funds and transfer the money between them. But what if you're affected by circumstances that are outside of your control? What if you're not allowed to use a centralized banking system to transfer those funds? Does that make Alice need those funds any less than she needed them before she could participate? The answer is no, right? So with blockchain, now we can transform fiat into digital assets and rely on cryptographic calculations and math to support the transfer of value. So this alleviates the need for a third party to take custody of these funds and ultimately become the deciding factor on whether or not Alice receives her funds. All right, so let's go ahead and dive into the DeFi timeline. First things first, in 2015, we see the arrival of Ethereum, right? So this means the building blocks of DeFi are sown because enter smart contracts. And with that, we have early DeFi, right? We have USDC, MakerDAO, DAI, Aave, other lending and borrowing protocols. Then we have DEXs and AMMs, right? We see Uniswap and SushiSwap gaining popularity. Others quickly follow. You see many clones across L2s and various other blockchains. So 2020, reward farming becomes a household activity, right? Here you see two protocols, Beefy and Venus. And next up, 2021, the world collides with pop culture and blockchain, right? So during 2021, we saw a boom in NFTs and layer 2 solutions to scale DeFi. Now, what does this mean? You know, we had Polygon, Optimism, Avalanche, which is a layer 1, but not only that, but you have Bored Ape Yacht Club, CryptoPunks, etc. And with that comes the need for liquidity pools and reasons for users to participate in DeFi, not only to use digital assets to purchase NFTs, but to start participating in liquidity pools and actually receiving incentives. So let's go ahead and take a look at this DeFi timeline here. As you can see, in 2019, we have some bubbling interest at $0.21 billion. Then we see June 2020, $1.91 billion. And then reach this peak here at $248 billion in November of 2021. Then after this, we kind of experience a little bit of a crash and a building period where we're now at $48 billion total value locked according to Statista. So a little bit of upside. What is this upside? Well, it's kind of hard to really pin that down, but one way we might look at it is the traditional finance assets under management timeline here. So currently, we're looking at $122 trillion of assets under management in traditional finance. So these are things like portfolio management, long-term CDs, et cetera. So will we be a part of this DeFi timeline? I'll let you go ahead and answer that. So let's go ahead and dive into the diverse world of DeFi. First things first, we have stable coins. So these provide a low volatility asset to get involved with, and they are pegged to underlying assets like the US dollar, but it's also worth mentioning that there's other stable coins and other tokenized assets that are also pegged to underlying assets like carbon credits, gold, oil, etc. Then we have lending and borrowing. Again, taking out the middleman of a centralized entity or centralized authority, aka a bank, and allowing users to participate in financial instruments such as lending and borrowing. So here we have Compound and Aave. And next up, decentralized exchanges and yields farms. So these are really the backbone of DeFi because they allow users to deposit tokens into a liquidity pool, and then using that liquidity, users are able to start participating in trading, swapping, etc. So we'll answer the question, what is a liquidity pool? So liquidity pools are the essential components of the DeFi ecosystem, and they enable decentralized trading and offering rewards. So simple way to put it, users deposit tokens, they receive LP tokens in return, and those LP tokens hold value. Once they make the withdrawal, they can reap the benefits of their incurred rewards, or there may be a fee structure associated with a liquidity pool that they can also benefit from. All right. So where are liquidity pools used the most? So really popular in DEXs because when you start a decentralized exchange and you need users to start participating in trading, how are you going to get that? Are you going to go the centralized route where you start a crowdfunding campaign and have to go through a bunch of jump through a bunch of hoops to be listed on a centralized exchange? Or could you potentially just start a liquidity pool and have the community start participating in this way? So here are some popular decentralized exchanges, Uniswap and SushiSwap, and here's an example of what a liquidity pool looks like. So you see the Cake BNB, Cake BUSD liquidity pool pair. The incentives right here, 43% year over year, and the total liquidity stake there. All right, so some of you might be asking, hey Julian, why Stellar and why not just Stellar? Sorry, I ruined that one. Why not just Stellar? So Stellar baked in AMM liquidity pool functionality into the core in protocol version 18, released in November 3rd, 2021. But we only support one type of swap, which is a constant product fee, with a 0.3% fee. Now, what does this mean? Not only are we spending time developing the best project to put forward, but we're also losing time because these solutions are already available in other ecosystems and they're already scaling. So enter Soroban smart contracts. These really open up the floodgates of innovation because now it's up to the users, the builders, the innovators to implement their own custom logic within these non-traditional financial instruments. So with that, we'll cover how would you build one of these things, right? So we'll begin with the smart contracts portion. So every liquidity pool is essentially made up of three functions. So we have deposit, swap, and withdrawal. So this allows users to deposit 2 different tokens into a liquidity pool, and they will receive pool shares in return. So you can also get on your mobile device and check out the QR code right there and follow along. First things first, we start with authorization. This is a really cool point to kind of highlight here because since we're using Soroban authorization, we're actually leveraging native functionality within the Soroban SDK. So no longer do we have to rely on third-party crates, et cetera. It's all built into the Soroban SDK and some great functionality leveraged throughout your smart contracts. So we then get those reserves, we calculate deposit amounts, and then we're going to go ahead and transfer token A and token B from the user over to the liquidity pool. Then we're going to go ahead and mint those pool shares to the user wallet. We're going to set the state with our variable here, new total shares. Then we're going to go ahead and mint those shares and then update the states, update the reserves in the state of the smart contract. So next up, we have swap. This simply allows users to swap between 2 tokens. So you're essentially depositing or selling a token and buying a token. And again, we're going to follow the same pattern here with authorization, fetching those reserves, calculating the sell amount, because we have to maintain an invariant of 3%. So no matter how large or small the reserve scale, users who support this liquidity pool by providing liquidity will always earn a 0.3% fee. Then we're going to go ahead and transfer those sold tokens from the liquidity pool over to the user wallet, and then we're going to calculate new invariants and verify that they hold, and then execute that swap. So we're either going to transfer in A or transfer in token B. Then we're going to go ahead and update the state there, and again, by calling the method put reserve A and put reserve B. All right, withdrawal works the way that you would think it works in the reverse order of deposit. So a user redeems the pool shares, we verify withdrawal conditions are met, and then we adjust those reserves. So following a similar pattern from before, authorization, transferring the pool shares from the liquidity pool or from the user over to the liquidity pool. We then fetch the balances in total shares, calculate the withdrawal amount to ensure that we're not making a withdrawal under the minimum withdrawal amount. We then burn those pool shares and then execute the withdrawal by transferring A or B from the liquidity pool back to the user wallet. Then we then update the state again by putting our reserves. And here we're going to do a quick example of, this is how we actually streamline dApp deployment because, when you use a shell script, you can actually call multiple Soroban CLI functions in quick succession. So here in this example, you'll see that we're connecting to the local deployment or the standalone network here, and then we're going to build the contracts, deploy token A and B, initialize those tokens, and then we're also going to do the same thing for the liquidity pool. At the very end, we'll go ahead and build the TypeScript bindings for these smart contracts. So one point I forgot to highlight is that we're actually creating a token admin account, which we're then going to use to initialize token A and token B. All right, so now that we've deployed our smart contracts and built the TypeScript bindings that we can use in the components for the front end, we'll go ahead and talk about how we utilize those. Chad, the floor is yours.
All right, thanks. Could we turn off this screen real quick? I want to talk about something without the slides up. How many people here have used Soroban CLI? All right. How many people here have heard of ABIs on Ethereum? A few. Great. All right. How many people here have used NPM packages? All right, almost everyone. And how many people here have used TypeScript? Great. All right, so ABIs are the weakest thing. One of my favorite things about Soroban is that the types for the contract, what functions it exports, what arguments it takes, and even the comments from the author of the smart contract are all published on-chain in a custom section in the WASM that's uploaded. What this means, the contract types is essentially what ABIs are in Ethereum, only they include the comments also. This allows us to build really powerful tooling. So if you've used Soroban CLI and you've invoked contracts, in that little script that was shown, the initialize.sh script, it was invoking the contracts to initialize them, to set up the fungible that are needed. I think all 4 of those contracts needed some initialization. So whenever you type Soroban contract invoke, and then you pass in --network, --ID, you do another little --, and then everything else after that --, so that's sometimes called the slop. This is a pattern that's used in a lot of command lines, such as npm. If you do npm run script name, you can do --, and everything after that goes to it. Cargo run --, everything goes to the cargo command that's being built. So in Soroban contract invoke is doing the same thing. It takes everything after the slop and passes it to an implicit CLI that's built on the fly for your smart contract. This essentially gives every smart contract on Soroban its own CLI. Every smart contract is its own program. It has its own interface. It takes its own arguments. The author of that contract defines all of those things. So it should have its own CLI. What does this mean? How does this translate to the JavaScript world? After talking about it a little bit, we thought, why not every contract gets its own NPM package? So that's exactly what we implemented. So slides back on. We'll show you what that looks like. With the TypeScript bindings, we'll call it, generated libraries, TypeScript bindings. I feel like the language is a little bit undefined still, but it's on-demand NPM packages for every contract. So again, this gives you full type ahead in your editor. So if you've used TypeScript, it's generating a TypeScript library. The NPM package contains a source directory with some a index and an invoke.ts, and they're actually readable. You can go in and look at them. They're fairly easy to follow. And then you don't need to necessarily follow them because they also have the full power of TypeScript. So whenever you import the functions from these generated libraries, you've got full type ahead in your editor. You've got the comments from the original code author. You can just use anyone's contract. Comments from original author. It also then works with any UI library. It's not React specific. It's not Vue specific. You can use it with Svelte, or you can use no UI library at all. And generated from the on-chain contract type definitions. And it handles some of the trickiest parts of Soroban. XDR, if you've had to hand author XDR at all, it's no fun, very error prone. This handles a lot of that for you. So it looks like this. We've got Soroban contract bindings TypeScript. You give it the network, the contract ID, tell it where to put it. So in this case, we're putting it in the node modules /LP. Yes, we are generating it directly into the node modules folder. This feels a little dirty. We found that it works the best. Local libraries are a little finicky to work with in NPM. I feel like this is just a bunch of bugs in NPM. If someone wants to fix the bugs in NPM, that would be great. Working with local packages should be as easy as working with published packages. It is not. So you might want to put them right in the node modules folder, or you might want to do it a different way and include them in your dependencies instead as file packages. But then once you do that, you can import them. You import this capital C contract and a networks object from LP here, matching the name where you exported it. If you smart deploy, instead of exporting a capital C contract, it will export a name, like the name for that contract. Smart deploy gives you named contracts. Smart deploy is going to be highlighted tomorrow in the ecosystem pitch session. I think that's what that's called. At what time? Okay, tomorrow morning, I think. So check that out if you're curious about Smart Deploy and how you can use it. So let's say we use it with Smart Deploy. We do const liquidity pool equals, and we instantiate our library. And we say new LP, and we pass it networks.futurenet. Why do we do that? This networks export is kind of splitting the difference between just exporting the interface of the contract and letting, if the contract author wants to publish this to NPM, if the contract author wants to publish this to NPM, then they can also say, like, okay, these are the different networks that I know I support. On FutureNet, I'm published with this contract ID. On testnet, this contract is published with this contract ID. And on mainnet, it's this one. So you can pick which one you want to use. But you got to bring your own RPC node, right? That's kind of the idea here. On testnet, on FutureNet, you can use the test endpoints for the RPC nodes, but we're making you specify it as practice for mainnet, where you need to bring your own. So once you do that, when you do liquidity pool dot in your editor, it's going to tell you all of the functions, all of the methods that are exported from that smart contract. It's going to show you all of the comments from the original contract author for all of those methods and what arguments it needs to take, all translated to native JavaScript rather than Rust or XDR. So let's go through and look at examples. Another thing that I want to highlight, you can use this for your own smart contracts, or you can use it for someone else's. So we're going to go through an example of a front end that was built by Cheesecake Labs for a liquidity pool, but the liquidity pool smart contract was built as part of the Soroban examples repository. So if you go to github.com/stellar/Soroban examples, you'll see or if you follow the QR codes that Julian put up, you'll see the smart contract code there that was authored by a different team. And now someone else was able to go in and build a front end using those. So there's a little bit of they reimagined what they could do with the front end, and there's a little bit of a mismatch between what you see in the UI and what's actually passed through the contract in some places. So we'll go through that quickly. This is when you're depositing. This is the full front end. You can see here you can deposit, swap, withdraw. We're going to go through deposit first. This is a zoom in on depositing. So here we're depositing. Someone thinks that USDC and Bitcoin should be at parity, 1 for 1. So that's what would happen if there were nothing in the liquidity pool and you deposited 15 each. So that's kind of our imaginary example here. But anyway, liquidity pool deposit. We've got this desired A, desired B, min A, min B. We can see 4 inputs. And we're saying 2 is the caller's address. It needs to be signed by the caller. Actually, on the left here, we've got the Rust contract method, right? That's what the smart contract author designed, how they designed the interface. You've got the 2, which is an address. Desired A, desired B, min A, min B are all 128-bit integers. And then when we call it from the front end, we have to pass all of those again. So again, here in the UI, we've got just this in, out, or like token B, max slippage. And then the front end is going to go through and do its own, right? Like this front end author was able to do their own math and say like, okay, we need to pass these other things to the smart contract. So there's some like front end math happening to calculate min A, min B from that max slippage. So imagine that math happens and now we've got this min A, min B. But passing them to the smart contract kind of couldn't be simpler. One thing you might not be familiar with in JavaScript is big int. How many people have used like bn.js or bignumber.js? Or there are all these libraries for handling really huge numbers because they used to not be supported very well in JavaScript. They are supported well in JavaScript now. They're called big int. It's native in JavaScript. Look it up on MDN. It's fantastic. So we can skip all those external libraries and just use native JavaScript now, which is delightful. And if you're not familiar with the ampersand, that's doing exponents. So we know that these, or we're imagining here, I guess, that this is actually not accurate for Bitcoin. We're saying desired B, we're imagining a desired B has 18 decimal places. So we're saying the number that they entered times 10 to the power of 18. So that's all that's happening there. That's the math that we're showing. And then again, there's some stuff that needs to be done with max slippage. You could design a contract that just takes these three inputs, right? And then and then all of the math that we're hiding here would be done in the smart contract. So if your team was building both the smart contracts and the front end, this would be even simpler. All right, so let's go through and we'll look at swapping. So swapping, again, the front end, we're saying, I want to put in 12 Bitcoin and get out 33 USD. Wild historical amounts there, I suppose. And then max slippage of 5%. And again, off-screen math happens, and we turn that into what the smart contract needs. The smart contract needs the buy A, how much you're actually getting out, and then the in max. In max is calculated pretty directly from this max slippage. The thing I want to show you, very close parity between what's in the smart contract and what's in the front end. Actually, I didn't mention E, this end variable. That's always the first variable to every Soroban smart contract. If you went to G's talk earlier, you saw that already. And then you're saying, again, the 2 needs to be the person who signs the transaction. You're saying, give me the out amount, and I'm going to put in this A amount, and it's going to max out at this number. So then we just await it. I've got a laser, I can point. We await it using async await, and that will return once the transaction is finalized on chain. So it will wait for full, not just for it to be submitted to the network, but for it to be finalized on the network. You can change that. There are other arguments that this takes, and again, full type ahead, so you can kind of explore that just by adding a comma after this closing bracket here, and you'll see what the other arguments are that you can pass to all of the methods exported by these generated libraries. Moving on to withdrawing, this is the first one. This is another one. We're just saying, I want to withdraw 15% of what I have in there. And then we do a bunch of math to turn that into these 4 different things. Again, you're saying to me, you're saying how much you want to withdraw, and you're saying at a minimum, I want to do these. Those are calculated, again, from the slippage. This one has a return value. This is how Rust does return values. And so here you can see that we are saying const out A and out B equals await that withdraw. So we'll await for it to be finalized on chain and then return it to you. So that's it. That is what building Soroban looks like very roughly. The stuff around it will change, but the interactions with Soroban are that simple. So our conclusion, DeFi with Stellar is ready for you. We can't wait to see what you build.